How does CAP theorem affect NoSQL database choices? Have you ever wondered how the choices you make in backend development can impact your NoSQL database selection? One key concept that plays a significant role in this decision is the CAP theorem. This theorem outlines a fundamental trade-off in distributed data systems, which includes many NoSQL databases. The CAP theorem states that in a distributed system, you cannot guarantee all three of the following at the same time: consistency, availability, and partition tolerance. You can only achieve 2 out of these 3. Let's break this down further. First, consistency means that every read request receives the most recent write or an error. This ensures that all nodes see the same data at the same time. Next, availability means that every request receives a response, but the data returned might not be the most up-to-date. Lastly, partition tolerance means that the system continues to function despite network failures or communication issues between nodes. In the context of NoSQL databases, partition tolerance is essential. These databases are distributed across multiple nodes, which can experience network failures. Therefore, when a partition occurs, the trade-off is always between consistency and availability. This trade-off directly influences your choices when selecting a NoSQL database. For instance, if you choose a database that prioritizes consistency and partition tolerance, you might sacrifice availability during network failures. Databases like MongoDB and Redis fit into this category. They ensure that all nodes have the same data but might become temporarily unavailable if a partition happens. On the other hand, if you opt for a database that prioritizes availability and partition tolerance, you may serve stale or inconsistent data temporarily. Examples of these databases include Cassandra, CouchDB, and these systems remain as operational during partitions but may not reflected the latest data across all nodes. Interestingly, while databases that combine consistency and availability theoretically exist, they are not practical in distributed NoSQL systems. This is because you cannot sacrifice partition tolerance in such environments. For backend developers, understanding the CAP theorem is essential when selecting the right NoSQL database based on your application's needs. If your application requires strict consistency, like in banking systems, a consistency and partition tolerance database is preferable. Conversely, if your application prioritizes uptime and can tolerate eventual consistency, such as social media feeds, an availability and partition tolerance database might be the better choice. Since network partitions are inevitable in distributed systems, partition tolerance is a must-have. This makes configurations that only focus on consistency and availability impractical for NoSQL databases. Many NoSQL databases offer tunable consistency, allowing developers to balance consistency and availability according to specific use cases and application programming interface requirements. This flexibility supports backend development by enabling tailored data handling strategies that align with server-side logic and performance needs.